Okay. All right. So welcome back, everyone. Welcome back to the final of the lightning talks. So this is the last of the presentations that we have scheduled on in this mentor stream. For the next few minutes, we'll have Drew Botts from GeoRobotics, and Drew is going to speak to us about automated tipping and cueing between a satellite and a drone. So without further delay, I'll hand over to Drew. Over to you, Drew.
Okay, and I'll have to start off with an apology because I don't have a satellite or a drone. But I do want to talk about tipping and queuing between different systems and how that works with connected systems. But yeah, sorry for the wrong title there. I think that might have been a tougher. Well, hi everybody. This will be a little short, but I wanted to start it off with like a live demo first, and then kind of go into what these tipping and queuing processes kind of look like, and what we're continuing to do in implementing them in a more user-friendly way. So right now, I am sharing the screen, correct, with the map?
Yes, we can see the 3D visualization.
So this is a access camera I have here in my window. You can see the video feed over on the left side. And it's connected through connected systems to Open Sensor Hub with regular pan, tilt, and zoom controls. And so what we've done, I think I've demonstrated a little bit before. I don't know if everybody was there before, is how these pan, tilt, zoom values, when geolocated, we can start translating lat, lon, altitude into pan, tilt, and zoom controls. And so the first process I have connected is one to take the lat, lon, altitude from this cesium map and provide that to the camera as pan, tilt, and zoom values. And so we'll see the frustum of the camera update along with the video feed, and it turning and pointing towards those locations. It even will take in altitude from the cesium 3D space as well to account for that into the pan, tilt, and zoom. So it's not just rotating around. So it's taking actually like lat, lon, and altitude into consideration there. So that's kind of the first step. This is one step further than just a regular control stream. It's taking an action and converting that into a control. It's kind of like your first step in the tipping and queuing through connected systems. I'm going to go ahead and add another visualization here. It's just me today, so this won't be quite as dynamic as I wish it would be. But I left an Android phone outside. And so we should be able to pick up this. This would be similar to essentially any kind of system that would be publishing its location in connected systems, but I happen to have an Android phone on me. Okay. So down here, this is the Android phone. It looks like I've lost my point marker for the other one. This is an Android phone. I'm on the second floor, so that's why we have this altitude difference. This is out laying in my yard. But what I can do is then change this process from my GeoPTZ process over to my Android to pan, tilt, zoom. And as soon as I do this, we should, well, let's go back to where we're looking here. You should see this change. And so now it's going and looking over in the direction of the phone over here. If I had another helper here today, I could get someone to run around the neighborhood, and so it would follow their location up to date. But right now it is just static, just throw it out in my yard. But I wanted to talk about what that kind of looks like in connected systems, and Open Sensor Hub and SensorML. So these processes are described in SensorML. I don't know if anybody's familiar with it, but if so, then this is a very familiar view. It's broken down into XML, and it's describing the systems and the data streams and fields that we want to put as inputs into this process. And then it describes the process that we put it into, and then it also describes our output, what we want that data to be described as coming out in the standard. Right now, this is probably the more, and also here it's describing our variables inside of that process too. This one, for instance, has hard-coded variables for the location of the camera, but these can also be variables that come in from observations of that system as well. One thing that we are doing is trying to build a more visual workflow for this, to where this is completely a prototype right now, but this is kind of the direction we're going, is to where we can have a visual builder for these processes, to put together tipping and queuing and control streams and modifying data visually and on the fly a lot easier. Right now, it's as simple as just selecting your process. You could come and edit your inputs and your parameters. And you can also edit your device, which camera you're connecting to, and so on. So this one is for the geo pointing. So it takes in parameters, and it is just waiting for a connected systems control message to come across. So when I was clicking on the map, it was formulating a connected systems request to say, here's the location I'm submitting to that process. For more tipping and queuing, I have on that Android, it's every time that Android creates a location observation, it's sending that to the camera. But that could also be refined into, say, a weather alert, or if something is in a bounding box area. Those are just more parameters to add to a process. And so for that process, it's not, the input is not a control stream. It is actually connected to that Android system. And that's where we start this and control. And for this one, this would be for a drone example, taking in an Android location to then task a drone with the parameters it needs to tell it to go to a location. So we have written these up, and we have done these where we're taking an Android location or a laser rangefinder and tasking a drone to update its location and move to another place. So on all this, is there any questions?
Okay, thanks, Drew. Are there any questions or comments for Drew? So, so effectively, so I'm looking at this and I'm thinking, okay, so effectively what we have there is an actuator, right? It's you're controlling the camera or the platform on which the camera is mounted, and all of that is being controlled, or at least the connected systems API is enabling communication between the client application, like the the browser or dashboard, and and the actual physical device. Am I right in thinking that all of that is using connected systems?
Correct.
Okay. Oh, cool.
Sorry, I'm gonna re-add this one where I can click on the maps, which is I can click around it.
Okay.
Yeah, so this is all using connected systems. It was something we were doing before the older standard, but it translates just as easily over.
Okay.
And not only are these systems described in connected systems, but the process itself is also described in connected systems and in SensorML. So it just like how we would describe observations and control streams. It's in a system. The process itself also publishes those and has fields and definitions along with all of those.
Okay. Okay, now that's awesome. And things such as like the field of view and etc. I mean, those are parameters on the the inputs to the process, etc. And would you by any chance be able to just show us what this SML document looks like? Or I mean,
For which one?
for this process, if it's easy to pull up and just show us the SensorML document.
Yeah, let me.
Or at least one that's similar to. I'm just I'm interested in seeing how the sensor is described including this process, etc.
So for the access camera, and I guess just to touch on the frustum that we're describing here, right now I'm describing that I don't have the camera lens model, so I'm describing that just based on Euler angles or Euler angles with a pinhole camera model, so just a basic field of view model. But what I could do is I could make a matrix based on the lens design so that this could be more accurately representation. We'd see a little bit more skewing based on lens distortion here, but I'm just using a basic one for this. And so on that axis camera, can go to the data streams. And actually what I'm doing with the axis as well is when I first deploy this camera, it doesn't have orientation or a GPS sensor. So I actually manually input its initial location and its initial orientation.
Yeah.
And then when I send a pan tilt zoom control, I take that value of the PTZ and I make that update the orientation based on the difference. So if it was originally oriented at 000 Euler, then the pan and the tilt will update those values so that it represents where its current viewing angle is.
Okay.
And then on the I guess the Android to pan tilt zoom, this one doesn't have quite as large of a description.
Yeah.
But yes, the output here is just the pan tilt zoom, and then on the control, it's just taking in a flat line altitude. So it's a very simple description there.
Okay, understood. And the video feed, is it video or are you sending across still frames or image sequences? What are you sending across?
So for video, the way we handle it is we describe every frame in SensorML. So it's an image is an array of red, green, blue value, an array of an array. Let me see if I get a good of the RGB values. And so I wonder if I can do so right now it's wrapped in all of the descriptive data, and then the result is just going to be compressed binary, so we can't see it here. But that way we have everything timestamped through connected systems and can replay that and access each frame independently.
Okay, but the codec. So I mean it's a frame, but it must be in some, in some encoding, whether
yes,
whether JPEG or I don't know, PNG or something, or even if it's video, whether MPEG, H.265, 264. So what I'm wondering is, I'm looking for something that gives me a clue.
That tells you the structure.
Yeah.
Yeah, let me go look here. So this one I believe is in H.264, but
Okay.
I'm looking for where that encoding is described. And I'm not sure, maybe it's not getting written properly in this driver. But yes, that is important to know too, for all the different encodings.
Yeah. Okay, because that's also a hook for this for Gimme, the new ISR imagery standard from NGA. So that particular standard supports HEIF, or it's a profile of the HEIF format, and it supports both still and motion imagery. So potentially, what it means is that connected systems, I mean, what you've got, I think, supports it, but you would need to advertise the fact that you are serving imagery in a specific encoding. So one of the things testbed 21 is going to recommend is, or one of the things that testbed 21 is recommending is that NGA registers a media type for Gimme files. So that potentially would mean that a connected systems implementation could advertise to say, the frames will be in, I don't know, image/HEIF colon Gimme or something, a media type that a client application would immediately recognize. So I think that will be an important hook for how we connect connected systems to Gimme and demonstrate that connected systems can support the Gimme ecosystem.
Okay,
that's something to note. Cool. Well, excellent demos. Thank you so much for showing us that. Are there any other questions or comments for Drew? Okay, hearing none. Thanks again. Let's thank Drew for an excellent presentation, please.